Hello viewers and welcome. This is ARC's 2010 project, Ground Edge Axe in U-square analysis. Now the aim of my project is to evaluate how U-square differs between a low edge angle and a high edge angle ground edge axe. If I change the edge profile between two axes, how does the U-square differ between them? But first I need to make the two axes, so this forms stage 1. Now the raw material I'm using is basalt. Basalt's a very hard material, and it does take quite a long time to shape. Now ground edge axes is one of the more prominent tools in Australia's archaeological record. In the Wallagamumma, which is a site in the Northern Territory, archaeologists recovered a 35,000-year-old axe. And recent research in Carpenter's Gap, archaeologists recovered currently the world's oldest ground edge axe, dated between 46 to 49,000 years old. Now the purpose of the belt sander is not to achieve the final product. It's only here to achieve the initial edge profile. Now you want to be really careful of the dust because it contains silica, so you should be wearing a respirator when you sand like this. And here's the results from that sanding. This is axe 1, which is the low edge angle axe. And this is axe 2, the high edge angle axe. And they're still dull and they still need to be sharpened. And the process I'm going to use to sharpen them will form stage 2 of the project. Now I decided to use a more traditional method using a sandstone block with some water, and I decided to add sand and water together to form a grinding paste. Whoops! I get that water, there we go, much better. So I'm just mixing the sand and water together to form this paste, and the purpose of this paste is what it does is it removes material much more aggressively from the surface of the edge profile to give it a nice sharp cutting edge. Now the process of sharpening does require quite a bit of time and effort to complete, so you do need quite a bit of patience to do something like this. Now while I'm busy shaping this axe, I'll discuss about U-square analysis within archaeology. U-square analysis is an important tool within lithic analysis, and it evaluates the tool surface to determine what the tool was used for, what kind of damage did it sustain, and what inferences can this provide about the tool's life cycle. This is usually combined with residue analysis into a combined approach which has demonstrated in the past the ability to create robust interpretations from lithic artifacts. But for the purpose of this project, we're just going to be focusing on U-square analysis. Now the grinding paste over time will lose its coarse nature, so it needs to be maintained by adding sand and water to essentially rebuild it. The act of grinding the grinding paste means that the particles within the paste loses its coarse nature and turns into the silky and smooth complexion that you can see now. Now the ratio of water and sand is actually quite important. Too much sand and too little water and the lithic will catch, just like that. And too much water, the lithic will essentially just slide off the sandstone block. So here's the results. This is axe 2, the high edge angle axe. And I managed to achieve an edge profile of 74 to 75 degrees across the cutting edge. And this is axe 1, the low edge angle axe. And this one has a much more acute angle at 53 to 54 degrees across the cutting edge. Now you might have noticed the edge damage along the cutting edge, and this will lead into stage 3, which is a very important process, the U-square analysis of the manufacturing process. It's important to establish a baseline before we use the tool so we don't misinterpret any of the diagnostic features later on. So I'm starting off with axe 1. Remember, this is the low edge angle axe. It's at 0 strokes because we have not used the tool yet. So the striations, they're right across the edge profile. In figure 1 you can see one highlighted, this long linear scratch. This is on a negative light image. The striations show up as black marks. And on figure 2, which is a normal image, you can see the edge damage we saw earlier. Now this is at a 500 times magnification using a digital omniscope. Now I'm using Robertson's 2005 terminology from her PhD thesis as well. Now moving on to axe 2, remember this is the high edge angle axe. It's at 0 strokes because we have not used the tool yet, and we see clearly more striations. Figure 1 and Figure 2 are the same image, but Figure 2 is a negative light image, and again you can see the striations highlighted. So now that I've established my baseline, I can move forward with the project. This is stage 4, creating U-Swear. So 1 stroke represents 1 impact. I'm striking the wood perpendicular to its surface with both axes. The wood I've decided to use is pine. It's not a terribly hard wood, but it's not a soft wood either. Oh, I missed it. I was aiming for the mark there. Now I've decided to use the stroke method as opposed to the timing method. I would have fatigued at different rates, so I wanted the U-Swear to be as even as possible between the 2 axes. So I'm being very careful to count the amount of strokes I do per axe. So at this stage I achieved 400 strokes. I decided to stop here and conduct stage 5, U-Swear analysis at 400 strokes. Starting off with axe 1, remember this is the low edge angle axe at 400 strokes on the ventral side. In figure 1 we start to see more edge damage starting to accumulate. This is again repeated with figure 2. We can see edge damage is right across the cutting edge of axe 1. Switching over to the dorsal side, remember this is figure 1 and this is the original edge damage we reported during the manufacturing process. However, figure 2 shows new edge damage after 400 strokes as well. The striations are still there, however this was due to the manufacturing process. Switching over to axe 2 at 400 strokes, remember this is the high edge angle axe. There is a nasty striation on figure 1, as you can see here. And again, repeating what I said about axe 1 and figure 2, the striations are still clearly here, but remember this was due to the manufacturing process. On the dorsal side we see that very little edge damage has occurred at all. Axe 2 is very different to axe 1 in that regard. Again, figure 2 showing very little damage at all. None was identified. So that is the U-Swear analysis conducted after 400 strokes. Once I achieved 800 strokes, I moved to stage 6. This is U-Swear analysis at 800 strokes, starting again with axe 1. Remember this is the low edge angle axe. On the ventral side we see figure 1, the edge damage that was reported at 400 strokes. However, figure 2, we start to see evidence of major dulling and edge damage as well. Moving on to the dorsal side, we can see in figure 1, remember this is the original damage we reported during the manufacturing process. However, at figure 2 we see even more damage reported and possible polishing as well. However, this is an omniscope, so I'm a bit hesitant to call it polishing just yet. Axe 2 at 800 strokes, remember this is the high edge angle axe. We still see the striations from the manufacturing process, they are still there even after 800 strokes. At figure 2 however we start to see evidence for edge fracture with that little notch in the middle. Switching over to the dorsal side with figure 1 we can see striations are even still there at 800 strokes. And with figure 2 we can again see evidence of edge fracture with that little notch right in the middle of the figure. So that is the analysis at 800 strokes. We're moving on to the final stage now, stage 7, conclusion and reflection. Starting off with a summary of axe 1, here you can see the images 0 strokes, 400 strokes and 800 strokes. This axe was definitely more susceptible to edge damage. This is due in part to what I suspect is the more acute edge profile. There's less material, it's more sharp, but it's far less durable. And when you compare this to axe 2, again we can see 0 strokes, 400 strokes and 800 strokes. It was a far less sharp axe, but because it had more material behind it and because the edge angle was much higher, it was much less susceptible to edge damage and was far more durable than axe 1. So my conclusion is the low edge angle axe with an edge profile of 53 to 54 degrees will show a diagnostic U-Swear after 800 strokes. In comparison, the high edge angle axe with an edge profile of 73 to 74 degrees will show significantly less diagnostic U-Swear after 800 strokes. In the future, this experiment will definitely improve with an increase to the stroke count. 800 is just not enough for this type of experiment. And with the use of a proper reflective microscope and possibly even SEM, scanning electron microscope with the preparation processes, this experiment would be far more successful. And as I leave you with my references, I'd like to say thank you for watching and I hope you found it useful.